So in this video, we're going to look at similar shapes. So we're going to look at how we can use the scale factor to find a missing side, how we can use it to find an area, and how we can work with volume. And finally, we're going to finish off by looking at a real exam question. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and I've got the example on the right, which is you do. So looking at this first question, what's important here is in the exam, you will be told that the shapes are similar or mathematically similar. Okay, so that's key. The fact that they're similar means that this shape, the bigger one, is an enlargement of this shape. So all the angles inside them are the same and just the sides have changed. So the first thing to do here is find two matching sides that you've been given information for. So straight away, I can see that this side and this side I have the information for. So how did this shape go from 2 to 6? Well, it must have been enlarged by a factor of 3. So what we call that is the scale factor. So the scale factor for this shape is 3. So now we know what the scale factor is. Well, how do I find x? What does x match up to on the other side, or this side here? So how do we go from this side to this side? Now, because the shape's getting bigger, we are going to use the scale factor and multiply. So we're going to times that by 3. So that means x is equal to 4 times 3, which is 12. So press pause and I've got the example on the right. So hopefully that press pause and I'll go at this. So you can see straight away the matching two sides are this one there. The scale factor for this is going to be 4. And get the side that matches up with x is that and that. So to go from this small shape to this big shape, we are going to multiply by 4. So 2 times 4 is 8. So x is going to be 8. And don't forget the units. So looking at this one. Now, again, with this one, we're going to look for two matching sides. So the two matching sides that I can see, again, are the two at the bottom here. So to go from the small one to the big one, we are multiplying by 3.5. So the scale factor for this shape is 3.5. Now, one thing worth noting here is x now is on the smaller shape. So we are going to go from 15 to x because those are the two matching sides. But this time, instead of multiplying, we're going to divide by 3.5. And the reason we're going to divide is because when we go this way, the shape is getting smaller. So you can then do 15 divided by 3.5. And if I type that into my calculator, I get an answer to 2 decimal places of 4.29 centimeters for x. So again, hopefully press pause and I'll go at the example on the right. So straight away, I can see the scale factor for this is 3. So if we go from there to there, we are multiplying. However, to go from here to here, when the shape is getting smaller, we are going to divide. So divide that by 3, and we get x as 4 centimeters. So in this case, we've been given the scale factor in the question. So we've been told that the scale factor is 3. So now we just need to think, is the shape getting smaller or bigger? Well, to go from here to here, the shape's getting bigger. So we are going to multiply by 3, and that is 30 centimeters. And again, in this case, so please press pause now to go. The shape is getting smaller when you go from there to there. So we are going to do 12. We're going to divide that by the scale factor in the question, which is 4. And that gives me 3 centimeters for x. So here's some practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers. Mark your work. So now we're going to move on to looking at how the area comes into the whole square factor thing. So with this one, we have got linear scale factor of 2. So we can see from left to right, the shape goes, the shape has sort of doubled in size. And the way we can sort of write that out is we have scale factor, we have a linear scale factor and an area scale factor. Now we know the linear scale factor is 2 because we figured that out. So if I get the area for this shape, that's 10 centimeters squared. And if I get the area for this shape, that's 40 centimeters squared. Now, if you look at the actual area, so going from here to here, the area has multiplied by 4. So the linear scale factor is 2 and the area scale factor is 4. So one thing to bear in mind here is that there is a relationship here. So if you have the linear scale factor as x, the area scale factor is always x squared, okay? So if I said to you the linear scale factor for something is 3, you can tell me straight away that the area scale factor is going to be 9. And equally speaking, if I said to you the area scale factor for something is 36, to go backwards, we just square root. So that is going to be 6. Okay, so that is the relationship here, x and x squared. So moving on to now looking at area scale factor. So although the questions asked us to find x, which is an area in here, we can see straight away, we want to start with what information we know. So we know that, and we know that side. So we know to go from here to here, you can multiply by 3. So we have I'm going to be a bit more specific now. We have the linear scale factor of 3. And using what we've just learned, straight away, you should know that the area scale factor is going to be 3 squared. So that's going to be 9. Remember, the relationship between this is x and x squared. So now you know what the area scale factor is. We can now apply it to this area. So to go from this area to that area, since the shape is getting bigger, we are going to multiply by 9, and that is 45 centimeters squared. So again, hopefully you've pressed pause and had to go at the example on the right. So the linear scale factor here is going to be 4, and the area scale factor is going to be 4 squared, which is 16. So remember, the relationship is x and x squared, like that. And if I multiply this by 16 as the shape is getting bigger, that's 160 centimeters squared. So moving on. Again, first steps first, we are looking for a matching pair to find the scale factor. In this case, we can use the linear one. So to go from here to here, we are timesing 2. So the linear scale factor is 2. The area scale factor is 2 squared, which is 4. And now in this case, we are going from a big shape to a small shape. So we are going to divide by the area scale factor, which is 4. And that gives me an area of, so I'll write that down here, x is equal to 25 centimeters squared. So again, hopefully press pause and adequate this. So we have the linear scale factor of 3, and then we have the area scale factor of 3 squared, which is 9. So again, we're going from a big shape to a small shape, so we're going to divide that by 9, and that gives me x as 9 centimeters squared. So in this case, we have been given the scale factor in the question, but if you read that carefully, it tells us the linear scale factor is 3, okay? So the linear scale factor has been given to us as 3. Now, the question is asking us to find x, and x is inside here, so we know it's an area. So we need the area scale factor, that is 9. And now we can go from here to here, since the shape's getting smaller, divide that by 9, and that gives you 30 centimeters squared. So again, hopefully press pause now to go at this. So in this case, you've been given the area scale factor, and what you're looking for is a side, so you need the linear scale factor. So we know that the area scale factor is 9, and we can find the linear scale factor by just getting the square root of that, so that's going to be 3. And now, since the shape's getting bigger, we are going to times by 3, and that is going to give us 6 centimeters. So here are some practice questions for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. Here are the answers, mark your work. So finally, we've got volume to look at. So we already know the relationship between the linear scale factors, so that's the sides, and the area scale factor is x and x squared. And our volume is x cubed, okay? So that means if someone says the linear scale factor is 2, you know the area scale factor is 2 squared, which is 4. And then you know the volume scale factor is just going to be 2 cubed, so that's 8. So hopefully you've pressed pause and had to go at the next one. So that is going to be 3 squared for the area, so that's 9. And that is going to be 3 cubed for the volume, which is 27. So with the next one, we've been given the area. So to go, we find the linear one first by square rooting it. So if you square root 25, I get 5 here. And then to find the volume, I'm just going to do 5 cubed. So that's 5 times 5 times 5. That's 125. Now looking at the next one, we're going to square root 49 to get the linear scale factor, which is 7. And then we're going to do 7 cubed, which is 343. Now with the last one, when you have volume, I normally always like to start with finding the linear scale factor first. So if I cube root that, so in your calculator, that would look something like that. That gives me a 3 here. And then if I square that, that gives me a 9 there. And for the next one, if I cube root that, that's a 4 there and a 16 there. So the whole idea of this exercise is just so you know the relationship between them is x, x squared, and x cubed. So now moving on. So both shapes are similar. Find the volume of A. Okay, cool. We need to find the volume of A. We can't do that immediately. We can start with whatever we know. So straight away looking at this question, I can say that the linear scale factor is 2. So to go from there to there, you're timesing by 2. So we can straight away say that the area scale factor is going to be 4, and that the volume scale factor is going to be 2 times 2 times 2, which is 8. Okay, so now we've got all the scale factors. It's told us that B has a volume of 1000 centimeters cubed. So to find the volume of A, we are going to do 1000, divide that by the volume scale factor, which is 8. So if I do that in my calculator, I get an answer of 125, don't forget the units, centimeters cubed. And that is your answer. So hopefully you've pressed pause and I'd go to the next one. So again, we've been asked to find a volume. The shapes are similar, so that means one is an enlargement of another. So start with finding the scale factors. So we can see we've been given two sides, so I can find the linear scale factor of 4. I can then go ahead and find an area scale factor, which is the square of that. And then I can go ahead and find the volume scale factor, which is 4 cubed, which is 64. Now that I've got that information, we know that A has a volume of 640. So we are going from a small shape to a big shape. So I'm going to multiply. And sorry, I should have also mentioned that here. With B, we were going to a smaller shape, so we divided, okay? So we are going to multiply that by 64. So I'm going to do 640 times that by 64. Given A is 64, and that's that. Yep, 640 times 64 on my calculator, and that gives me 4,090 centimeters cubed. So that is quite a big number, and that is the volume of B. So looking at this one now, so it looks like it wants us to find the volume. We've been given the surface areas, so we know that the area scale factor, also worth mentioning, the area in 3D shapes is referred to as the surface area. So it's the same thing as finding the scale factor for area. So the area scale factor here, I can see from there to there, we are multiplying by 4. So I've got that. Then I know that the volume scale factor is a little bit tricky to figure out here. So it's always best to figure out the linear scale factor as soon as you can. So to find out the linear scale factor, I just need to square root 4, and that's 2. And then from here, I can find the volume scale factor, which is going to be 2 cubed, which is 8. So in this case, since the shape is getting bigger from here to here, we are going to multiply that by the volume scale factor. So that's going to be 500 times 8, and that gives me 4,000 centimeters cubed. And on the right hand side, again, hopefully you've pressed pause and had a go. You've hopefully started with finding the area scale factor first, so that's times 3. And then so this one gets a little bit tricky. So you've got then the linear scale factor, which is the square root of 3. You don't need to write the value out for it. We can just leave it as square root of 3. And then if you cube that in your calculator, so we can get the volume scale factor. So that's just going to be, you're going to type that like this in calculator, and you get an answer of 3 root 3. And you can just leave it as that. So now all we need to do is divide this 1500 by 3 root 3, because the shape is getting smaller going from right to left. So if I just type that into my calculator now, so we have root 3, and if I cube that, I get that, and then 1500, divide that by that, and that gives me 288 to 2 decimal places. That's going to be 68 centimeters cubed. So moving on. So in this case, we're asked to find the surface area. We have been given the volumes, so I can use that to find the volume scale factor. So to go from here to here, if I type that into my calculator, that is going to be times 27. So I know the volume scale factor is that. I need to get the area scale factor, but it's easier to find the linear scale factor first. If I cube root that, that's 3. And the area scale factor there is going to be 9. So since the shape is getting bigger from here to here, if I use the area scale factor times that by 9, that gives me 900 centimeters squared. And again, hopefully you've pressed pause and I've got the example on the right. So again, we're going to start with finding the volume scale factor. So that's going to be 2000, divide that by 250, and that gives me 8. So I know now that the linear scale factor is going to be 2. And again, the only reason we're finding the linear one is because it's just easier to go down to. And now that we have the linear, all we need to do is square it to get the area one. So area scale factor is 4. So this is what we're really interested in, is that 4, because we need the area scale factor to get that. So that is going to be that times 4, and that gives me 400 centimeters squared. So there are 2 questions for you to have a go at. Press pause and have a go. Where are the answers? Mark your work. Here's an exam question for us to look at. So feel free to press pause and have a go at this yourself first, and then I will go through it. So looking at this question, the first thing you want to spot is the fact that you've got a triangle, and then you've got another triangle on the right. And it's much easier to solve this question if you draw them both out separately. So if I draw the two out separately, like so, and if I draw the smaller one out here like that, yeah, let me just draw that again so it's nicely lined up. Nice. So that is A, that is C, and that is E. So that is the big one there. And then the smaller one is B, C, and D. And that's just a case of labeling the information they've given me in the question. So E to C is 8.1 centimeters. D to C is 5.4 centimeters. D to B is 2.6 centimeters. And it's saying work out AE, we'll call that X there. Right, so the two matching sides we have is that one and that one there. So if I find the linear scale factor, so if I just write that down here, linear scale factor, so I'm going to do on my calculator here, 0.1, divide that by 5.4, and that gives me 1.5. So it wants me to work out AE. The relationship there is going to be that matching side and that matching side there. So since the shape is getting bigger, I'm going to multiply that by 1.5. Now, so the trick really in this question is to spot the fact that this is two triangles, because if you don't spot that and you try to solve it without drawing the two separately, and that gives you an answer of 3.9, it can become quite tricky if you just try to do everything just by looking at this shape and not realizing there's two triangles. So here's a second exam question for you to have a go at. Press pause and have a go. When you're ready, press play for the answers. So I say press play for the answers. I'm going to go through this as well because it's an exam question. So with this, again, it's the same thing. You need to spot the fact that it's, well, it does say in the question, it shows two right angle triangles, but you do really want to extract the two out. So if I extract the first one, and I extract the second one, not sure what happened there. There we go. So E, B, and D, and then we have A, C, and B. Now, if I read the question, it says AD is, where is AD? AD is 9. Okay, interesting. AD is 9 there. DE is 2, so I can label that there. Just change colors. So that's 2 centimeters. D to B is 6 centimeters. I can label that here as well, 6 centimeters. Okay. So then I know what A to B is altogether. So that's just going to be, excuse me, 9 plus 6, which is 15. So that's going to be 15 centimeters there. So now that I've got all this sorted out, what is the question asking me for? CB. Right, which is that one there. So, right, so let's start with the usual. So we have the linear scale factor. So two matching sides. That side matches that side. So 15 divided that by 6, it's 2.5. So we've got the linear scale factor of 2.5. Cool. We can't find X. Hopefully you've spotted that straight away. But we're going to instead try to find this side Y. And we're going to see if we can use that to find X. So we know we're definitely interested in, the question wants us to find this. So we're really interested in this triangle here. So we want to find as much information as we can for it. So let's just find Y. So how do you go from here to here? The shape's getting larger, times it by 2.5. So if you do 2 times 2.5, you get an answer of 5. So if I just rub that off, that is going to be 5 centimeters. And you know this is a right angle triangle, so we can use the Pythagoras theorem. So we are going to do, it's the smallest side we're looking for. So we have x squared is equal to 15. Square it, and subtract them two. So that will be 15 squared minus 5 squared. And that means x squared is equal to 200. And then if I square root that, that gives me 14.14 centimeters to 2 decimal places. So this was slightly more advanced exam question, but again, it started off with that whole concept we've been learning about scale factors, and then just taking it from there. Had a little bit more thinking to it, but yeah, that's all good. So that is the end of this video. Thank you so much for watching, and as always, I'll catch you next.